without air.
Yeah.
It's more material, but it's more cost effective to make it.
Yeah. It's more material. I mean, those things are super expensive. However, if you do open source rubber, thermoplastic urethane, once again, you're going down to like low, like it was, I counted like $75 or something in materials per. If you do, it weighs 500 pounds. It's heavy. It can go anywhere from like 200 to 500 pounds. So say you take 300 pounds, but remember what our cost was, 14 cents. So that's $42 in rubber. Remember, so we had the thermoplastic urethane at 14 cents for scrap source. If that's the material cost, then we're under $50 per tire. So it's good. It's really good. I mean, it's big and it's heavy. So yeah,
Much cheaper than the current market for sure on
yeah.
each
And
one.
those things, what are they? Like $800 for one airless tire?
Correct.
Yeah, they're crazy. So yeah,
Okay.
yeah. Okay.
Should we start on the work document?
Yeah, yeah. Let's go in there.
I I didn't focus this week on the 3D printer
Mm-hmm.
components. I
Mm-hmm.
did find some suppliers locally
Mm-hmm.
that they do the work, and before building my own, I just want to make sure how much it costs outsource it first before doing the current printer.
Mm-hmm.
Why? Because I kept doing the cost analysis of the document,
Mm-hmm.
and I found a new surprise regarding the cost. That one of the most expensive, it's basically sunshade and bird net per plant, and that putting plants closer to each other, I meant 2.6 meter between lines and zero point 0.6 between pots instead of zero point 0.7 to be able to have 6,410 pots per hectare.
Mm-hmm.
That's per plant, 5.12. I'm on slide number 1. Should I share the document on the chat?
Got it. Go ahead.
Okay.
Okay, you switch right from 3D print. You didn't do 3D printers. Bill of materials cost is about 500, but moving on to you switched right into netting.
Yeah, correct. I didn't finish it. So it's
Whoa.
5.12 plant.
Mm-hmm.
So that's the most expensive cost.
Oh wow.
And I was wondering if we could focus one on understanding on FreeCAD how to do material analysis in the case to understand in the design how much per material do I need.
Aha. So okay.
That's
Okay.
on the 3D printer part to keep moving on, and on
Mm.
the substrate and burn. I was thinking if we could work on the kilowatt project you have on the thermal batteries.
Mm-hmm.
In that case, if the kilowatt is very attractive, maybe instead of sunshade, would be developing a PV panel cover.
PV panel cover. Yeah. So yeah. So let's see. What do you got for per plant? $5. Well, so if PV panels get down to like 20 cents per watt, and you've got like say a 500 watt panel times 20 cents is $100. Way higher, but maybe like, are you saying for replacing?
Doing a per plant instead of doing the whole hectare, having a
Yeah,
big
yeah.
PV panel could develop that kind of sunshade in that specific spot.
Okay, you the netting that you use is also used as sunshade. No, or those are two different
So
products.
two different products. They could be the same, but I wouldn't be able to move it during the season. It would have to be fixed instead of retractable.
Because of the heavy weight, if it's also shade.
Correct.
How do you? So, what are your thoughts if? So, say we've got like a. Um, let's take a note. Like, if the size. Let's get a baseline size of 500-watt panel or $100, because if it's say 20 a watt, 20 cents a watt, which I think is doable. What is the size?
Of the pot, you mean?
No, let's see. I'm just googling. It's 7.4 by 3.7 feet. About 28 square feet. 28 square feet. And what's the spacing between plants again?
Putting more close would be 2.6 meters between lines and 0.6 meters in line between pot.
0.6 by 2.6 meter spacing?
Yes.
Okay. Yeah, that's hard to beat with that. If you do say, for example, like, do you have any feeling for how many? Because we can probably do like 20 for, if you do 50% shade, like every other, there's space in between every panel. You're getting the panel cost down to $50. How much would 25% shade do? Is that doable?
Yes, that's what we use basically here, between 20
25%.
to 30, correct? 25 being the average.
So you're at $25 for the panel instead of $5.
How did you calculate that?
If a panel, so one panel is about 28 square feet. So compare 28 square feet to 0.6 by 2.6 meter. What's that come out to? 2.6 times 0.6 is 1.56 square meter. So 1.56 square meter to square feet.
16.79.
So let's call it about 17.
Yes.
Wow. About 17 square feet. So one panel covers 28 divided by 17.
$1.64.
Wow, so that's not bad. 1.6 plants. If you, yeah, so if you do 25%, if shade is 25%, then we cover 6.4 plants. Holy cow. What? We're beating the price of sunshade?
Probably.
Hold on a second. So we cover 6.4 plants for, so we've covered 6.4 plants with one panel for $100. Sorry, so for about $100. So it's about 16 or so per plant. Yeah, about. Yeah, we're getting close. A factor of three. Now,
And yes,
and if you're using that energy, yeah, that makes sense. Like if um, are, do you have a huge need for energy? Not until we get into actually making things like, solar hydrogen, we're actually storing all that energy, right? Like, and then running tractors with that. We're not there yet, right? Um,
I would need energy specifically for the summer to be able to be cooling. And that was my second
so
point.
cooling.
Yes, instead of waiting 10 months to have a harvest,
Mm.
it really can be done in 6 months. But we would need to control better the summer to be able to have the plant on optimal weather development. That would really help me
Mm.
to move the harvest closer to the months of winter, which are more better priced, at least for me as a producer, than being able to harvest in the months of spring.
You're already beating the timing compared to the US, and getting that earlier by cooling helps you even more. Is that
Yes, that's a possibility. How much would it cost to cooling? Cooling for the blueberry plant is 7 Celsius. That's a chilling hour. So that would be the measure. How can we get to 7 or at least 5 Celsius to be able to create that effect of chilling hours in the moment we want to create it?
what happens when you chill them to that level?
The plant takes it as a chilling hour. It's not that happens an effect on the leaf or fruit. It can be totally harvested if that's the case. It's just the plant set this hour as a chilling hour. So with certain amount of chilling hours, let's say 150 to 200, that's when the plant starts to do some flowering, and that's where the fruit comes from. So it's the change of receiving the chilling, so the plant gets the signal of saying, okay, it's time to do flowering and fruit, and that's where the development changes from creating vegetation like branches and shoots to creating the flowering on each of the branches or and shoots.
Are you trying to push for more than one season during the year then?
That would be the best optimal, but as of now, I would say just pushing some months to be able to be at winter and harvest during November, December, January instead of doing February, March, April. That's my other interest with the kilowatt. So I just try to integrate different concepts in order to be able to make it this more feasible. I wasn't expecting the panel to be as cheap as BirdNet and Sunshade, but maybe that can take into the formula to
Ah,
make this into something doable.
yeah, that's pretty interesting. So, for fruiting, does
Uh,
that, if you get fruiting earlier, does that mean you get longer fruiting, or no, you just harvest at a different time?
to just harvest at a different time, but if the plant is in an optimal weather state. In our case, let's say we prune in May and we're in 40 Celsius. Then June, July, August, sometimes we go to 45 Celsius. The blueberry plant, when it's more than 32 Celsius, it just stops working. It protects itself and it doesn't develop anything. So going back to the case of adapting the weather, let's say put it more cooler to be at least 32 Celsius, that's going to help that during those months, it's going to happen the
Hmm.
vegetative state. That's the part of using the kilowatts of the thermal battery, since they are cheaper, and mix them with the kilowatts of the LED light, as in a case of use, to be able to achieve all of this in 6 months.
Oh man, that's at scale. I mean, wow. Um, and that's on a scale of like you're talking about acreage, right?
Yes, I want to make a model for at least a hectare as a way to modulate and scale by models. That would be my intention.
Hectare, yeah. So, okay, so this gets into you need shade, which the panels could get you. So you got cooler. You need enclosure of the system from the outside weather. Man, how do you do this? This is like, this gets into pressing compressed earth blocks. So your shade, you've got structure, and you got PV on top. Oh man, that's far out. I think it's. Can you see it? CEBs. I mean, CEBs are 1 cent a block for gasoline if you run it from gasoline, but now they're free if you're running it from solar. So you got a solar CEB press. You're pressing dirt. How's your dirt there? You got clay? You got clay like we do here, like 20%?
Yes.
Okay, so so we're gonna press a CEB structure, put PV on top, and we're gonna grow your blueberries in the climate controlled environment. A little bit of heat pumping. I mean, heat pumps ain't cheap though. They're like $1,000. $1,000 for like 10 kilowatts or so. What's Oh, I can give you a price. So let's see, heat pump sourcing. Go to the wiki heat pump sourcing. Oh man, this is far out. You're like, I wasn't ready for this, but you asked for it. This is, if you look at heat pump sourcing, you got $1,000 for 24,000 BTU. That's for low temperature heat pumps. You see it? $1,000. Okay. What is 2,000? Let's talk kilowatts. 24 BTU to kilowatts. What is it? About 15? What's
Not
my
sure.
guess?
I research here.
7. It's only 7. It's only 7 kilowatts. Okay. Model for a hectare. So let me make a copy of this slide, duplicate slide, and let's just keep evolving that. Climate controlled acreage. Well, we're the only guys that would be able to do it if anyone's able to do it.
And that's because of the kilowatt cost. That's why I started thinking about it as an option to optimize the rest.
I mean, like the Chinese greenhouses that are buried to the side of the land. So
Never heard.
that's out there in an appropriate technology world. You can dig up somewhere Chinese cold temperature greenhouses where they're buried into the earth. They have a sloping roof and a stem wall in the front, but that's earthworks. We can go up with CEB if we got a free CEB press running on solar, free block.
Yes.
So we just get this thing cranking out block. It just lays layer after layer. It's solar. It'll be investment into getting that thing on a, like if it's automated, it'll be on a rail or a slow moving robot. Rail or slow moving robot. So you got to grade the field to be level. Then you can just travel on the ground, and then you're laying block for free at the solar power. Solar, like if it's solar power, free. So yeah, you could say enclose like 20-foot wide spans. Nominally, 20 to 30. I would say maybe 30, so you got less wall. Um, we'd have to look at, let's say 20, 24 feet, or let's say 30 feet. I think 30 feet is doable with, um, what's the lowest cost to span trusses? It's probably the rebar trusses. So CB's 30 foot, or yeah, 30-foot rebar truss, PV on top. There you go. Throw in some spaghetti insulation under the PV so it doesn't get too hot. Uh, and you're climate controlling. Now, if you've got thermal mass, a few heat pumps in there, a few thousand in heat pumps was going to cool that. Depends on your insulation. Now, if there's thermal mass in the block, so we're talking about 1 foot wide walls, there's a lot of thermal mass there. Probably on average between day and night, just like, Pueblo villages, like the Native Americans who lived in the dirt homes, adobe homes, that style, they're cool inside, aren't they, right?
Yes.
How cool.
I don't know the difference. I've been into maybe in my life in Sedona, just
Mm.
visiting, and it was very different
Yeah.
inside, outside.
So imagine, so where do you get the light? The light would be LEDs, so I think we're limited to what is LED cost. Because now we're controlling the thermal, because we've got dirt and PV and insulation. So the bottom line determinant, I'm seeing LEDs, if that is the light. Otherwise, you're sending in partial light. Now the bad part about the partial light, oh, you get a lot of thermal energy there. That's the only problem, right? So you'd need a lot of cooling. If a square meter's got a kilowatt, every 7 square meters you need oh man, every 7 square meters gets you 7 kilowatts of heat into that greenhouse. That's impossible. That you need like a heat pump for every 7 square meters. You see the math there?
But
Solar is 1 kilowatt per square meter of energy. That's the facts for solar. So that's why greenhouses get so damn hot, right?
Mhm.
Every square meter is a kilowatt. So 24,000 BTU heat pump, 7 kilowatt heat pump, is only cooling a greenhouse of 7 square meters. That's absolutely impossible. You got to go to LEDs. That's like the back of the envelope calculations here. Let's write that down because this is pretty cool. No pun intended.
Question is based on the reference of each season, I would say.
Yeah?
Ones are hotter,
Yeah.
ones are not that hot. That's
Yeah.
got up on the desert.
Yeah.
How to see the correlation between that specific weather and inside the greenhouse? I mean, the use of kilowatts or LED lights. There has to be less in certain weeks of the year, correct? Less use.
Uh, I'm not getting your question. What's the question?
The usage of kilowatts or LED lights.
So power consumption of LEDs?
Yes, basically that's the question of
Not an
units.
issue, not an issue. The question is their cost. They take, I think, for a square meter, I think they take like 1/5 that of solar because they're optimized for the right wavelengths. They're about 20%, if I'm correct. Chat it. How much do LEDs cost to illuminate 1 square meter? How much wattage does a square meter of LEDs for growing cost? How much energy? My guess is 200 watts.
what type of LED should we use as an example? 100 watts, 150. What would be the reference of?
Well, per square meter to illuminate, like you're growing plants, you're talking about your acreage. Let's say, how much LEDs do you need per square meter of growing surface? Right?
Yes. I mean, it depends on how much coverage the light it's going to get to how many plants. Or it's going to be one LED per plant. That's a
No.
relationship.
No, LEDs are small.
Yes.
So a bunch of LEDs. Um, think of a grow light. I don't care about the number of LEDs. There's like a basic number. Okay, I'm gonna chat it. So you're asking for how much how much power do LEDs use per square meter? Just do that.
36.5 kilowatts per year of square meter. 1 square meter takes 36.5
Kilowatt hours.
per year, correct?
35 kilowatt hours per year.
Yes.
Okay, why?
On 100 watts of LED as a reference.
Oh, 100 watts of LED illuminate that square meter.
Correct. That's
All
why
I'm
I
asking is what you're asking for is the 100 watts. That's your answer already. So it's 10%. So each square meter requires 100 watts. Yeah, over the air it adds up to whatever. Like, not important right now. To calculate the basics here, you're saying 100 watts of LEDs is required per square meter.
Okay.
At 1,000 watt per. Okay, I'm on slide 2. So 100 watts. Paste the link at 100 watts per square meter of LED for plant growth. Paste me that chat.
Yes.
So highlight this. Yeah,
Yes.
and pump it in there.
I'll do that.
Okay, but I mean this. Oh yeah, there. Oh, there.
Is it right?
Yeah, I see it. When you say you did it, was there a lag of like 5 seconds there?
Probably. Yes.
Okay, it could. Okay, there's a little lag, maybe. Okay, cool. So, next question is a 500 watt solar panel enough to provide its own area of LEDs? What's the answer to that? Can you figure that out? Is that a relevant question?
Yes. That's going to be the source of energy.
So you got 500 watts. And how much area does that have? 2.8 square meters is 28 square feet. I call it 10 square feet to a square meter. About 2.8 square meter.
How you did that calculation?
So I look at 28 square feet right up there.
Yes.
So roughly speaking, a square meter is about 10 square feet. Let's see. How many square feet in a square meter? It's like 11, 10.7. So roughly 10. Like we're talking about, first principle, just like back of the envelope here. So about 10. So you got about 2.8 square meters. So how much do 2.8 square meters need? Only 280 watts. That 500 panels is, you can have extra energy from that. So you can have your LEDs. Ah, there you go. And you can do the cooling, no problem. So we're just saying that, okay, now you cover your, you got like twice the power that you need. You got 500 watts, you need 280.
per panel, per
Yeah.
50,
So
500.
two, 280 watts needed for the 28 square feet or 2.8 square meter, because we need 100 watts per square meter. 280 watts of LED needed for the 28 square feet. So we've got like 200 extra watts left over. So yeah, we're good. Awesome. So we're not limited by like land area for the self-powered LED greenhouse. Now the bottom line is going to be, well, these panels, I mean, you're talking 20, 30 years. So how long does your bird netting last?
10 years.
3x. We just matched the price of bird netting. That's insane. Good job, man. Hey, you're thinking. That's good. I wasn't even thinking this. I didn't think it would. I think it would be very feasible for high value crop like lettuce that, you get $1 per month per square foot.
They they do that already with on vertical farms. That's
Yeah,
their
yeah,
system they use.
more than that. Um, wait, let's have an aside and let's just for like the basics, so basic understanding. If lettuce gets you $1 per square foot per month, which is what we've done here in hydroponics, let's say we've done that. What is that figure for blueberries per square foot per month? So you've got, okay, let's entertain ourselves with that just to get a base.
It's
Do you know that figure?
I can calculate it right now. In meters is 1.56 meters what each blueberry plant takes. So we can do it by
Uh huh.
plant
Yep.
and then by. So we mentioned the cost is $3, and the volume it can create in second year would be 3 kilos.
At
And
3 per
then
kilogram profit.
yes, let's
Mm-hmm.
put that as well.
Let's say 3 kilogram yield. So you
Per
got $10. That's comparable to lettuce.
plant, 3.5 kilos you can have on second year, and on third to year 10, you can have at least 5 kilos per plant. So year one, it's basically 2 kilos. Year two, it's 3 kilos, and year four, and year three to 10, it's 5 kilos at least. That's how I would calculate to have
Yeah.
it when it's mature
So you're really talking about 5 kilos for the majority of the time.
of the
Times,
life cycle. Yes,
oh man, so you got $15 per square meter per 1.5 square meter. So about $1 per square. So you're literally equal with lettuce. So yeah, you can do this in a greenhouse. You can do lettuce is effective in. So yeah, you're right. You can do it. You can do acreage in the greenhouse, according to these economics, these first principle calculations.
one thing I didn't understand fully of this, yes, just going back to the
Hmm.
cost structure of doing the 500 watts and doing the cost calculation that you just mentioned. How did you get these numbers? And I'm asking
Yeah.
just what is on the ChatGPT, not because I know. I saw
Yeah.
different numbers.
Yeah. So which number do you want me to explain?
with a 500 watt
Yeah.
solar if it really can assure the use of the LEDs per
Okay.
space needed.
Okay. So let's review that question. Um,
Source to use. Source panel, use LED.
yeah. So solar panel question. Um, is a panel or is a panel equal sufficient to LED light its own what grows underneath it? Yeah. Is that our question?
Yes, that's a question. And before that, the 100 watt square meter. When I consulted the chat,
Yeah.
that how we got there.
You want me to explain how we get 100 watts?
Yes, I just want to be very precise since the beginning to
Yeah.
the end cycle to
Yeah.
make sense. Since I got everything from the chat, I just want to understand the behind of that.
Yeah. So we know that solar energy comes in at a kilowatt per square meter. That's basic physics of solar irradiation on this planet from the sun 93 million miles away. 1 kilowatt per square meter is all the energy. It's electromagnetic energy, it's light energy, but then it turns into heat. Okay? Uh, forget I said that. You got 1,000 watts in whatever form. The form it's in is actually photoelectric, and that's what Einstein discovered. Actually, he got a Nobel Prize for discovering the photoelectric effect. Did you know that?
About the Nobel Prize, no. The inventor, yes.
Yeah, Einstein. He didn't do that for like relativity. He didn't get a Nobel Prize for relativity. He did it for the photoelectric effect. The point is that in 1,000 watts of solar radiation, we can actually turn it to electricity, thanks to Einstein. he named it. But there's 1,000 watts. Now, the part that plants grow with is only a small part of the spectrum, right?
Yes.
It doesn't use like that 1,000 watts that comes from the sun. It just uses a small part. So, without going into further detail, I guessed, yeah, about 1/5 it might use up. And chat says it's about 1/10, right? It says it's 100 watt. What's it saying? It's how much do plants that grow well use up? They use up, you told me, 100 watts per
No,
square meter.
I mentioned that the example we made, say if you install 100 watts of LED covering 10 square meters, that's 10 watts per square meter. And then that calculation went into saying in a full year, you use 36.5 kilowatts per hour in each
Kilowatt
meter.
hours. No, kilowatt
Yes,
hours.
in the square meter.
Yes.
That was the reference that I
Okay.
didn't know if
Let's
I
go.
expressed correctly.
Let's get into that a little bit. So we're just going to validate the 10 watts. So it's actually not 100 watts, it's 10 watts per square meter. That's
Yeah,
ridiculous. Low. In other words, we're going to have those PV panels. You can sell most of that to the grid, and you're producing blueberries. So if it uses 10 watts, that's
per square meter.
1%. That's crazy. 1%. I don't get that. I don't believe that. I think it's more like 10%, because we know that the most productive crops convert, like sugarcane. They're able to trap like a few percent, and that's making mass. No, that's right. It's only a few. They try. No, that number. Let's explore that number. If that number is that low, it's like, wow, this is really good, because absolutely electricity from the solar panels is not an issue, right?
Yeah, I think the question for the chat was how much energy does LED cost in kilowatt per square meter? Then the answer, and then the other question was if a 500-watt solar panel is enough to provide its own area of LED. Those were the two questions referenced that
Okay.
we put in the work document.
Yeah. Yeah. Let's go through there and just start verifying whether chat is bullshitting or not. So it says 25 kilowatt hours for that square meter. Square meter of LEDs.
No, it's 36.5 kilowatt hour per square meter per year.
Uh-huh. About, let's call it about 36 kilowatt hour per square meter. Now, this is per square meter of growing surface, correct?
Yes, and that's using a 100 watts LED luminary that covers 10 square meter. That's the reference it got.
Per square meter growing surface. So that's at 10 watt LEDs per square meter, yeah?
I'm going to paste the answer here just to have it as reference where I got the information from the.
Yeah, I can click on that one. Let me see that one. Let me see what you're reading there.
It's on slide number.
I'm just clicking on the thing you already put in there. Oh yeah. Yeah, exactly. So that's exactly what it does. It's 10 hours per day. If it's growing 10 hours per day, you got 365 days. 0.01 kilowatt, meaning 10 watt per square meter, right? So 10 times 10 times 365. Yeah, that's correct. That's fine. So I'm amazed. So I'm going to go back into your chat. It's like, is that... Are LEDs really 10 watts per square meter of growing area? For example, for blueberries. What's it say to me? Are LEDs really 10 watts per square meter? No. No, it says 10 watts per square meter is roughly the lighting power density for human environments, not for plant growth. Blueberries, like most fruiting crops, grows far higher intensity than office or warehouse light. Okay, so you're talking about illumination. Oh, okay. Yeah. So you were talking about illumination for like offices. So what we need is, okay, yeah. Leafy greens, 60 to 100 watts per square meter. Blueberries, 120 to 240. Okay, so I was actually right. My guess was like 200 watts per square meter. So yeah, it's strawberries and blueberries. So you see that? Let me see. Let me share that chat with you. Copy link. So I'm gonna say. So this is not. This is for office space. This is for office lighting. Blueberries let's say around. It said 120 to 240. Let's say something like 200 watts per square meter. Yeah. Um, okay, so we're cool with that, but the question is, um, so are we getting closer to that? So we're saying, let me put that 200 watts per square meter. Let me put that. Can you see that now? Yeah. So that's why I said no. I don't believe it's 10 watts. Yeah, that's correct. It's not 10 watts. It's going to be about 10 times more. Yeah. Right. So we don't care about the yearly stuff, because what we care about is on any given day, do we have enough power for those LEDs? So if we need 200 watts and we've got 500 watts, for 2.8 square meter. Okay, so we're getting to basically, yeah, we're just enough to make them grow at the lower. So 500 watts for 2.8 square meter equals, are you following that?
Yes, I'm just thinking about the reference of current sunlight that we could get on this kind of design. If we think about the ceiling,
Yeah.
you're thinking of fully closing it and generating zero sunlight.
Yeah.
That would be your approach of doing this.
Yeah, because of the figure about how much heat comes in if you're getting light, full light from the sun. You know what I mean? Or you can consider, no, I mean, a lot of that stuff that comes in from the outside is, there's a lot of thermal energy that the plants don't use, but it's dissipated as thermal energy. See what I'm saying? So do you understand the idea of 7 square meters of greenhouse requires 1 heat pump?
On space, I cannot see it now.
So can you follow that if each square meter gets you 1 kilowatt of solar energy,
Yes.
then 7 square meters gets you 7 kilowatts of solar energy. Most of that is heat, because plants use only like that 10%, 10 or 20%. So most of it is heat, is dissipated as heat. So that heat pump, there's a 7 kilowatt heat pump, you need 1 heat pump for 7 square meters. Roughly. See what I'm saying?
On cost structure, does that make any sense for you?
No, because a heat pump is $1,000
Mm-hmm.
for that. So
Yes.
if the heat pump were lower cost, then you can do it, but it's we can take those to zero marginal cost too with carbon dioxide heat pumps. There's heat pumps that don't use exotic refrigerants, like the most advanced, some of the more advanced heat pumps use carbon dioxide as the working fluid.
Mm-hmm.
They're higher pressure than the normal heat pumps. I looked into this because you're looking at what are abundant resources, not like the refrigerants that whatever the modern heat pump uses. That's a human-made complex molecule. You can also do it on things like carbon dioxide.
If we took the indicator sunlight, we have more than enough. Sonora is with a lot of sun hours. So I would say we could eliminate LED lights and just find a way to make cheaper that 5 point something of current birdnet and sunshade into something with the OSE materials that currently has. Would that be an option?
Yeah, you can do so for this heat pump thing. When you chill them, do they have to have light?
No. Let's just go to the slide number number 21. That's where I put some of the answers
Yeah.
I was trying to communicate earlier. So by
Mm-hmm.
stages, the main indicators are photoperiod hours, the number of weeks that period is going to take, the optimal temperature. Of course, that's the average, but we can be around that average.
Mm-hmm.
The DPBs or KPAs, the relative humidity needed, or most of it the
What's
optimal.
what's what's DPV?
Let me find in English.
Kilopascals. I mean, that's pressure.
That would be pressure, but not in the plant world. Just give me 1 second and I'll answer.
Hmm.
It's something related to humidity as well. Vapor pressure deficit. That's DPB.
I don't understand. Explain it.
That's an indicator that has to do something with how the humidity it's inside that same place. I don't know the specific answers on agronomics. I just know it's an indicator the current advisor gets to know or
How,
gets to in this case.
how do you measure it?
I got this information from a weather website like MetaBlue,
Mm-hmm.
and they got this indicator as a tool or sensor. How do I measure it? I'm not exactly how to measure the vapor pressure deficit.
Okay. So, in this in this graph on 21, where's the chilling hours?
On floral induction,
But that says 21C. You told me like 7C.
well, that's optimal temperature average. If
Mm-hmm.
during the night we get some hours that are 7 Celsius and below, that counts as a chilling hour, and the plant needs to get to 100 and 150 to be able to start the flowering induction, and then it comes the rest of the process. So you can
Mm-hmm.
see this by stages, vegetative development
Mm-hmm.
that takes really 12 weeks. But as I mentioned before, on hot weathers, when it's below 32, that the plant just stops working. So that's why sometimes it takes 6 months instead of 3 to be able to have the full development.
Ah.
Then it's floral induction, then it's flowering, but that's after the chilling hours. And then it's fruit set harvest, and then it's the harvest. The harvest of the blueberries, they don't mature all at the same time, so sometimes some can be on fruit set and some can be ready to harvest. That, that's that's the main stages, and as you can see, the photoperiod hours, which those can be managed with the sun directly or with LED, as we were discussing earlier, they are different on the stages. The vegetative development that takes 14 to 16 hours, and it needs to rest the other ones. Then on floral induction, which is more close to winter, it just needs 8 hours of photoperiod.
Mm-hmm.
Flowering 10 to 12, and then fruit set goes back to 14. Harvest 16 because
Hmm.
it helps mature the fruit faster. So there are variation on the different stages. And I was thinking about the LED lights. They don't need to work 24/7. But honestly, we don't need the LED lights. I would say the main focus would be finding a sunshade burnet structure that is cheaper than the 5 point something I put on the document. The period of weeks, that's the an optimal state, but it can go faster or not depending on the location they're put on. And that's basically what I want to communicate. If we can get as close as possible to these kind of indicators, that would really get everything faster.
Explain to me why, if so, you're now varying the timing of fruit set, but if the volume of production is the same per year, what is the reason why you want to get those extra months? Is it because explain that? I mean, from the revenue perspective, it's same revenue, but you have more happy customers because they have blueberries 3 months earlier. Is that
Mm,
explain that?
no, not really. I'm talking directly for me as a producer of you. If we see the price of kilo packed product from, as an example, October,
Mm-hmm.
that's about 9 USD.
Mm-hmm.
November, it's sometimes 10 USD. December, 11 USD.
Mm-hmm.
January, it goes back to 9 USD.
Mm-hmm.
February, 7 USD. March, 6 USD.
Oh.
April, it comes all the US. Then it goes to 5 USD. And then US starts harvesting all together. And it goes even sometimes 4 USD. So the
Oh.
earlier, the more US dollars I get because of the season.
I see.
Winter is more profitable than spring. And then what I don't want to do is being in the summer.
Mm-hmm.
So because the US is there, I don't want to compete with the US. I want to complement. And also because the prices are much better on off season. That's the reason I want to become earlier, but it's not a must.
Okay. Okay. So, um, so between growing in a controlled environment where you control the temperature, you think just so there's two routes. One where you can control the temperatures, but if you do the shading part, are you still cheaper way to shade? You're saying no, you're not changing the seasonality, or you still want to change the seasonality?
At some point, yes, as we saw now, I think the costs are going to be much higher than just doing the conventional production season. So, answer, I would say let's go with low cost current season that we can achieve with sunlight. Later, if there are innovations in material cost structure and we're able to get those LED lights and do the cooling inside the greenhouse, it will make sense to do it earlier because we will get, maybe it's going to be a little bit more expensive, but if we get 9 USD per kilo instead of 5 USD per kilo, we're going to have a $4 difference accumulated by 7 years or 8 years. Depends how much we have the plant going on that specific season, if nothing changed on the US market.
So my question to you is, we haven't looked at the price of LEDs yet, though we said that the panels themselves are matching the price of the netting by their higher longevity of 3x, right?
Yes, if we view it that way, yes. But if we want to do a project of 10 years and compare it to current project, it's going to be more expensive on a 10-year
On a
time
10
frame.
year time scale, yes. Yes, it will be. Um, unless, what about this? Is there any options of actually selling the power? Or no, that's a ripoff, just like
There
anything
are
else.
limits on the current electric system in Mexico. You can give back certain amount,
Yeah.
it's not very much. So it's not feasible to sell it to a current grid.
Yeah, yeah, that's right. Um, okay, so because we just explored this and we said, oh, okay, for the panels, yes, it makes sense on the 30 years, but on a 10-year horizon, no, sorry, can't do it, right?
For
That's
now, because I'm focusing on being very low cost compared to current system.
okay, lowering the cost of the current system. So the question becomes, how do we get lower cost on the netting?
Yeah, sunshade and burn it. I
Yeah,
mean, burn it. I was thinking about not even using it and maybe opting for certain lasers that could help with that. I don't know.
lasers.
Yes, I have seen some studies of farms that are using lasers to really be able to scare the birds
Oh wow. Um,
as an option. But if there are better material alternatives, I would be open just to find an answer to lowering the cost of burnet and sunshade. Sunshade, it has to be at 25%. That's all we need.
mm-hmm, mm-hmm. Well, so of course the obvious answer would be 3D printed stuff. So we can take a look at that. But before we go there, um, are the panels, the agrivoltaic aspect, is that out of the question pretty much altogether? Because um, let me just review what we just said before. So on page
I
number
see
three.
two challenges. First one would be the cost of using it on the blueberry needs, since blueberry need a higher amount of light, and also the space that it would need. Even if we get heat, the heat tools you mentioned, much cheaper. Instead of 1,000, we get them by 100. They're going to take a lot of space, as I understood, on the growing space. Is that correct?
No, the heat pumps, they're going to take a
Yes,
lot of space.
that's not correct.
No, no, I mean, so the heat pump is just like you mount it on a wall, it doesn't take any growing space. So I'm just trying to process what we just talked about. So so our conclusion so far was that if we covered the field with photovoltaics and we could capitalize that, it's actually equal on a 30-year time scale. That's correct? So we're covering the entire field, and we're using that as your bird net slash shade, and we actually match the price already.
Just doing that correct. Just thinking about instead of sunshade and birdnet,
Yeah,
the PVs and doing it on a scale of 30 years, we can call it would match the price. But I'm looking to
yeah,
much current time.
yeah. So then we get into, okay, well, what's your bird bird netting and sunshade look like? I mean, those are going to be what, like PET or what? What's the current, say, sunshade made of? Let's start taking a look at it.
Mhm.
Can you break it down? Which is more expensive, sunshade or bird net? Sunshade, I would imagine.
Sunshade, yes.
Out of the 512, what's the breakdown? Do you know?
I have the document, I think, here on the work doc. Just let me make sure. Okay, I'm just gonna paste the link of the quote. And the quote was made specifically for a hectare.
All right, so I mean, let's take a look at what can be done by 3D printing. I mean, obviously you can 3D print it. Let's take a look at that. Um, so you're looking for the breakdown?
Yes, for the code.
Mm-hmm.
I'm not sure where is it now, but I will put it in the document as soon as I find it.
Okay. Can you send me a link to the sunshade and bird net that you use? So let's take a look at it and compare to what we can just plain 3D print.
Yes. You want to the technical data sheet?
Product sheet, like so a link to the product and its data sheet. Yeah.
On the work document, or where do you want?
Yeah. If you could just click on sunshade in your bubble one and link to that,
Okay.
and then birdnet link to that.
That's not the technical sheet yet. It's just the code of
Mm-hmm.
the supplier that he sent.
All right. Mm-hmm. Does the sunshade include both the material and the structures?
Yes,
Okay. Are the pipes, is that wood or metal?
that's on wood, the quote.
The posts are what? Are wood?
On the quote, sorry, I think I missed it.
Yeah, so on a bird net, when I click on the link to the sunshade, the picture, the posts in the picture, what are they made
Yes,
of?
of wood, but that wasn't the link I was trying to put. I will put the current quote.
Uh huh. Hmm. There's wire.
If you go into the prices bubble, the 5.12 USD,
Uh huh.
there, there you're gonna be able to open the quote where I
Okay.
reference what they use. It's in Spanish, but they do install as well post and anchors. That's what they do as additional work for being able to put the sunshade plus the bird net.
Hmm.
Just as a reference. And the document I did attach on sunshade, the exact technical data sheet. I think it is not working yet, but okay, should be working now.
Mm-hmm. 5 year, so 5 year life for the um, bird. Oh, sunshade. That's what's shown is 35% when the looks like it's more transparent than that, but maybe not. Okay. Uh-huh. Mm-hmm. So that's so both of them are like 5 year, but they last what, like 7?
Supposedly 10 years, could be 7. They just protect themselves with the data. They put less years in
Yeah.
case it happens.
Yeah. So in the document where you said 512 USD, that doesn't show 512. It's showing me like 9 per square meter. Is that nine US dollars per square meter?
Well, yes, that's one moment. Let me open that.
So that's way more than what you're saying.
Yes, because that's the one the quote I got just for the specific area of one third of a hectare. What I went to the 5.12, that's another quote that I couldn't find at this moment. I
Okay,
left it
okay,
on the computer. That goes for a full hectare. That's a 5.12 instead the 9
okay.
US dollars. Those are US dollars, correct?
Yeah.
But I will put that quote as soon as I find it.
Mm-hmm. Mm-hmm.
But it's same structure than the one I attached.
Okay. Now, do you have a feel for what fraction of this is, um, if you were to, like, for example, for the sunshade, um, let's see.
I do. I'm just finding that code and I'll put it because that's on each independent material. And I found it. We can see from here how much is cable, how much is
Okay.
unshade, and how much is burned per. It doesn't say per meter. It says by piece mainly, but we can find a calculation. Oh yes, it says by meter. One moment.
Hold on a second. For the shade and netting, are you talking about the entire operation being under that?
Yes, birds. They're I would say one of the biggest risks because when the fruit is starting to get ready or mature, they get first than the harvester. They're very smart, so they take many fruit.
Mm-hmm, mm-hmm.
On the work document, I did the quote of the specific material so we can see the cost structure, how much is materials and how much is, I would say, cement, concrete, how much of that is anchors. So if you go to the work document and you click on quote material, you're gonna find a link to the direct quote.
Yep. So
If we want to know, let's say, about the sunshade, it's a concept that it says 35%, almost at the end. Malla sombra, monofilamento negra, 35%. And that was per square meter, 14 Mexican pesos per square meter of the sunshade. Then if we go to the bird, this is by piece, and it says each piece is 500 multiplied by 200, so it's 1,000 meter. Okay, it's 2.95 of bird square meter Mexican pesos. I'll put it in document.
why is the 1,500? Uh, why is that quantity 1554?
The one, I didn't get the question.
So the quantity of Maya sombra on the filamento,
Yes,
35%. 1,554 square meters?
that's a total in the order. Why is that number?
Yeah.
Because I did have some that I recycled, so I
Okay.
did it the full area. But by unit cost on square meter, that's 14 Mexican pesos,
Okay.
like 0.60 USD. And the rest, it's concrete and anchors and post. It can be from metal or it can be from wood. So as I'm seeing the cost per square meter of sunshade and birdnet, maybe the strategy would be of using the materials that that work at low cost instead of trying to make more PBs. I don't know how you view it.
Okay. Okay. Installation is a big deal, right? And then, so you're saying that if the actual material is, so it's 21,000. What is your suggested strategy?
Not changing the birdnet or sunshade cost,
Mm-hmm.
but optimizing all the rest to make that installation.
And what does, yeah, like installation, right? So what does, for example, installation include?
Post, concrete, the made of the mix to be able to put the post at the concrete, then installing the cables, the metal cables to be able to hold the sunshade and birdnet
Mm-hmm.
and have it ready for you. That's like the main concepts, and all of the rest of the cost, it's labor. People doing that work of stitching, accommodating, and make it ready for the end customer.
Stitching what, like?
Like the sunshade. Let's say you ask for pieces,
Mm-hmm.
that pieces has certain limits of units of meters or
Mm-hmm.
height wide, and you start stitching enough together so you cover the area you want to cover.
Oh, that, yeah, they got, okay, because otherwise you have cracks.
Yes, and for the bird net you want everything closed.
Mm-hmm.
Sunshade, you want cables enough to be able to move it during the winter season, and you get more sun. That's the whole strategy. And why sunshade? Because the heat we have here and the radiation, it
Mm-hmm.
tends to be too much for the plant to be able to develop during summer months. Those are the main concepts.
You want to remove the shade in the winter. Keep the. Do you keep the bird netting on?
Yes, full year.
Why is that? Is if fruiting season is only part?
Because of the fixed structure currently we have on installations. If there's a way to do it cost effective of installing and uninstall, that would be another story. But
Oh, okay.
as the production site, having that is more costly
Mm-hmm.
than have it removed and put it again.
Yeah, yeah, yeah. No, that makes sense. Um, unless the both are done at the same time. So you remove both at the same time, like they're actually connected to each other. Two layers. Why couldn't? Why doesn't the is one material responsible for bird protection and shade, or is it two separate materials?
If it's fixed,
It's two separate materials, right?
right now, since I want to achieve a retractable, being able to move the sunshade in the winter months, they are two separate materials. But in a fixed case, where they just put the ceiling material as sunshade and it also protects from birds, and just on the side parts, they put the bird net. So they don't do two layers on the ceiling, they just do a single layer, and on the side part, they just close it with a bird net. But that's not retractable. That's not movable because since it's a single material,
Hmm.
you move it, then your protection for birds on the ceiling it's gone. That's the reason of having two materials on the ceiling part with bird net and sunshade because of the retractable part.
I'm not following the. So the
Retract,
you definitely want to get more light in the winter, right? And if you so what do the ones where it's not retractable? What do they do in the winter? They don't have enough light.
yes, they do have enough light, maybe not as much as they need to make
Yeah.
it faster, but that has worked
Mm-hmm.
as well.
Okay. So you want to do two different materials. Yeah. How do you? What are your initial thoughts on how do you? So how do you actually get this the labor down? Do you see a lot of savings there potentially?
Yes, that's the biggest part where I see the savings for sunshade burnet for irrigation systems. It's a labor strategy.
What are your thoughts on that? How do you start reducing it?
Understanding how to make it modular
Mm-hmm.
and don't need too many expertise or specific people that knows, as an example, one knows to stitch, the other one has to do concrete, the other one knows how to do installation in higher altitudes.
Mm-hmm.
All of that, how can I make it modular to be able to install it with a few people, and if possible, with a few machinery that helps on the
Mm-hmm.
weight part.
Yeah. What about the cables? I mean, how long do those last?
They always say 10 years. I haven't done a project with cables more than 3 years, so I don't have the specific reference. If I ask to people who has greenhouses with this structure, they talk about 7 to 10 years on a good functional cycle.
Mm-hmm. And these are what kind of wire? It's not stainless steel. It just corrodes after some time.
Yes. Let me see what's the term galvanizado in English.
Galvanized.
Yes, that's the only extra protection or term that has the cable. So I believe I'm not seeing here the opportunity directly, but with your experience on materials and building houses, maybe a good idea came how to optimize this cost part.
Yeah. Mm-hmm. Um, and the cement is that what's R150?
Mhm. I don't know if it's resistance, but as of now,
It's how strong it is.
yeah, it's Portland concrete.
Mm-hmm. Yeah, that's about 200 over $200 a meter cubed. Yeah, is that am I reading right? Price per unit is per meter cubed. It's 2,400 pesos, which is about it's over 200.
Um,
It's like $250 a cubic meter.
yes, I mean each bag has 25 kilograms. So here we're 100 kilograms. It's 24 pesos per kilogram. And the cubic meter, I'm not sure how they made the calculation. Probably they are not just putting the cost of the material, they are mixing the labor to install it on cubic meter versus kilogram. What would be the conversion? Just to understand what they might mean.
Cubic. How much does cubic meter of concrete weigh? I think it's like 1,500 kilograms or something. How much does a cubic meter? Let's see.
Not sure why the quote says cubic meter, but as of price here in Mexico, the Portland concrete per kilogram, it's at max 24 Mexican pesos. That would be $1, not $2 per kilogram.
Yeah, weight of concrete is about 2,400 kilograms per meter cubed.
Okay.
Yeah, so we would have to. Let's take some notes here. Tell me once again for your per kilo.
The cost,
Mm-hmm.
24 Mexican pesos.
I don't get that. That's I don't understand that. Is that if there's 2,400 kilograms per meter cubed, you're saying a meter A cubic meter is like $2,400? No.
No, no, 24 Mexican pesos per kilogram. That was your question?
Yeah, so that's about a little over $1 per kilogram, right?
Yes, on the quote I'm seeing here on the internet.
Um, how do you explain that if there's if a cubic meter has 2,400 kilograms?
Yeah, I was taking wrong numbers.
No, wrong numbers. But that what you've got in that quote there, that's per meter cubed, right?
Yeah, so that's 2,400 Mexican pesos per cubic meter. So 120 US dollars per cubic meter.
Yeah, yeah, yeah. That's right. That's the same prices. Um, right. So we don't look at the details of this. Um, so just for reference, this is like 1,554 square meters. So that's like, it's less than half an acre.
Yes,
Um, and that's costing you about $1,000 or so. Okay, so what do we want to do then? So do you want to then? Last time we were talking about the pots and growing material. Now we're talking about bird netting. So do we want to move from grow media and pots to sunshade bird net? Start on that as a priority.
for this current session, I would say yes. In the meantime, I will still work on the prototype of the filament biochar. It's not something I want to do this or the other. I will do both.
Mm-hmm. Mm-hmm.
But for now, yes. What would be the best strategy to do as lowest cost as possible? The sunshade and burn it. That would be the main thing to fix, or my wish to fix with lower cost strategies, since that's the biggest cost per plant.
Hmm. To comment any meaningfully on how to reduce the installation cost, like I would have to look at, just get more detail on what it looks like, the whole process. Um, and what about? I mean, maybe it turns out. I mean, 3D printing is. Can you 3D print actual netting like that? I mean, it's something to look into. Let's see. Let's see what chat would say. Can I 3D print bird netting? Yes, you can 3D print, but with caveats. Versus durable farm. once again, it actually goes straight to thermoplastic urethane, our favorite print. Um, I mean, there's no reason why we can't print it. The question is like if you're printing it, what the baselines probably and material costs are probably going to be low. So if we're let's once again get a baseline to see if we have good savings, any potential for savings there. But if you talk about a meter squared unit being about, it's less than $1, right?
We talk specifically about the
Yeah,
sunshade
the the 35%.
per square meter. It's 2.95 Mexican pesos. That would be about 0.10 USD per square meter. And the sunshade, that's about 0.60 USD per square meter.
Mm-hmm. So if you look at the, once again, what's the weight of that sunshade per square meter? Do we have that info?
On the technical data sheet, should be, no, I don't have it now. It doesn't come on the internet site, but I do have some at the field, and I could wait and do the calculations right there.
Mm-hmm. Let's see. I'm just asking chat what is weight per square meter.
What there is an option is to spend much less square meters instead of doing the whole hectare. Just do the exact plant site. So I'm gonna paste a website on the work document so you can see an example. And maybe from there, reducing the number of square meters, but it's gonna require certain structure, could be an option.
How do you reduce the square meterage?
Let me show you with a link. Okay, on the same bubble, on the 14 Mexican square meter, there's going to be a link that's going to take you to a supplier website. They have a product called Roto Protect. Please let me know if
Yep.
you see it.
Yeah. So Roto Protect.
Yes, as you can see, that has some structure that is able to open and close just by turning that metal structure. And at the same time, it just covers the specific line of the plants instead of covering the whole hectare. So by that, you're reducing the amount of square meters that you need of sunshade.
Yeah.
And that's retractable as well because these metal structures, it has certain functions that is just like it turns on. If it's north to south, it just turns on the other side, east to west, and the sunshade material, it just becomes on a single line instead of being
Yeah.
covering, it just puts together. That's one way of doing just the sunshade. And on that same idea, I was thinking instead of doing the bird net, doing the laser, that's going to help.
How much is the laser stuff? Is that any affordable? Have you looked much into it?
not in the cost structure, but I will have it ready for next session.
Yeah. Well, bird netting. Chat says it's only like 90 grams per square meter. 90 grams per square meter. So it's a mesh. I mean, there's no reason why you can't print it. The question would be, how do you print such a volume? However, that's not necessarily impossible because you can print it. You can print something that pretty much expands. Did you ever see like those, like the netting you see in the store where, like, say, netting for some fruit, where the netting could be very small, but when you put a fruit in it, like it's maybe that narrow, but when you put a fruit in it, it expands quite a bit, right? You know what I'm talking about?
No, I haven't seen that kind of netting.
Oh yeah, okay. Take a look at this. This is the idea, but stuff where expandable. So in other words, if you got a limited print bed, you can print stuff that you print. It's small, but it actually is much larger because it expands. Does that make sense?
How does it expand?
Well, because it's those meshes
Okay, I
are
got it. Yes,
stretchable. Yeah,
I'm seeing the picture now.
yeah.
Yeah,
Let's see.
and
So,
your idea of doing this is for the bird net?
yeah, both BirdNet or yeah, BirdNet definitely. For sunshade, maybe that's not as. There might be some advantages there, like you can maybe double the size as opposed to. No, I mean it could both. It has. You have to think about it. You have to think about the geometry, like expanding geometry. But it's definitely something to consider. So now, if you have a belt printer, you know the belt printers that print infinite lengths, right? You know, imagine you have something that's, you know, wide, maybe like say even 12 inches, but it's got that mesh. I mean, I could see it extend 5, 10 times. So why not? You could probably. Basically, what happens is you print it in 1 foot. Say it expands 5 times, but it shrinks because you're stretching it out. So it will shrink in length, but shorter than infinity is still acceptable, right? Because the infinite belt printer. You see what I'm saying?
Yes, I'm just thinking the two main indicators are going to be cost of production and cost of installation, even if it's, I know the material is not gonna be as tough as the other ones, but if cost let us do maintenance much cheaper than current ones,
Yeah.
plus the cost of printing, I think could be a deal.
Yeah. So now you'd have to school me on what exactly is the process for erecting those, and we can develop that. That's definitely worth looking into.
We're talking about specifically sunshade, birdnet.
Probably both, right? Or no? Or for which do you see as the important one for the maintenance part?
Both.
Yeah. Um, you said definitely for the shade, right? Because you definitely want to take the shade off.
Correct, to move it during the season.
Well, you're saying for winter you want to take it off to
Yes.
get better lighting.
Yeah, that's what I meant by removing the sunshade for certain seasons.
And do you know what improvement you get by removing it?
More sunlight.
Can you
on low.
quantify it?
There's a metric, but currently I do not know it.
Mm-hmm. Mm-hmm.
Winter has less sun hours, and the reason of moving the sunshade is just to get enough sun. By radiation units, I don't have it now. I will have it ready for next fall.
Yeah, the rotoprotect is interesting, and if you can reduce the amount of material or basically automate the shading part, yeah, right? So copy that idea. Open source version of that gets you like after what? Okay, so outside of the installation, what's the maintenance cost? Can do you, so there's installation. How much are you paying for in maintenance?
The cost that is by hectare industry wise, because I have never done it on scale,
Mm-hmm.
it's 150 USD per hectare. What does that mean on maintenance? It's basically having the crew labor to open and close during the season. That's like the cost average big producers get by hectare. 150 USD to being able to open and close. Now I don't mean that by fixings, and I don't have a specific cost of fixing, let's say, a hole that was made on the bird net or the sunshade. But that's basically labor. I wouldn't see other specific components to add to.
Open and closing. You mean removing the sunshade?
Yes.
Mm-hmm. That's not a lot then, right? That's not part.
No, it's not. It's more the challenge of getting labor to do it at
Oh.
a specific time and speed. So rotor protect idea,
Mm-hmm.
I think it's amazing because you just need two people on each side to be able to activate the mechanics for turning the sunshade into a single line.
Is the rotation you rotate it manually or it has actuators in it?
The rotor protect,
Yeah. You just move it manually or somebody has to go out there and do it or does it is it
okay,
automated?
correct, yes, one person per side.
Yeah.
They, they are, I think, 100 meter of length. So you get each 100 meters, two person that can just move that
Yeah.
with their force. So that's what makes it special too. It's easy to move.
Yeah. Now the thing is you would have a separate structure for bird netting.
Yes, that would need to happen if we keep the bird netting. If we go into the laser use, that could be another solution to not be able to not have to use the whole hectare. Just those certain sites of the hectare or site location directed to the plants.
Yeah. You know how at the airports they get rid of birds by some sounds? Like, is there any technology like that for birds?
It really doesn't work. I did try last season. I
Mm-hmm.
bought two speakers from a specific company called BirdX,
Mm-hmm.
and they say they work. And but birds are so smart. I mean, the first week, of course, they got scared at the different noises.
Mm-hmm.
The other week, they were really sure that it was some technology, and they were even stepping on the speakers that caused the noises. So it doesn't work long term. It works for 5 days. Birds are too smart for this.
Yeah.
So laser, that's a different story.
Sounds expensive, but maybe not if open source.
that's what I'm trying to find out. How can we open source it and just make it feasible for instead of doing the BirdNet, we can do this on the document. I pasted one from basically Home Depot. It's from this same company. I bought a speaker with noises that didn't work out, but this is just a commercial laser, which is 234 USD. That's on the bubble of slide number one, next to BirdNet, where it says Bird Laser. That's the hyperlink that it's going to go directly to the Home Depot Bird Laser as a reference.
Where's the hyperlink?
The hyperlink, it's on
Oh,
the
bird
bubble.
laser. Bird. Okay, yeah.
Yep, right there. And I will paste more professional ones, but I just want to make a reference of how this is nothing,
Laser repair.
nothing too difficult to replicate.
Oh wow. Is it supposed to work, or is it gonna be like the other thing?
Now, this has better, I would say, experience on the producer side. Not exactly this brand, but ones specifically developed, I would say, for vines, crops such as grapes, and they have a good feedback from the producers.
Mm-hmm. Is that system way more expensive than this, or?
I will look for it. I'm not 100% sure. I would say it shouldn't because of the capacity that the other laser can give versus this capacity that we see is very near focused. I have the information ready for next time.
Okay.
And also no more surprises about what I want to focus on next. The reason I made this change this current session is because I finished analyzing the whole cost of Blueberry project and suddenly Burnet and Sunshade, they were the most expensive concept.
Yeah. Yeah. Um, I mean, there's. I could definitely say the materials part. Yeah, we have to take a look at. Okay, can we open? Just 3D print that? And once again, at low cost, if it's like 60 grams per square meter, I mean, the cost is like nothing. So once again, we save significantly on materials, and then about the process of the maintenance. Yeah, we could think about the different systems. How do you make it more modular? How do you mount it more effectively? I don't have any ideas offhand unless I actually, if you want to like maybe prepare a doc for, okay, here's how the current system works, and how do we take a look at each of the elements of that netting system. I can't picture it offhand, but if you give me more information on that, we can take a look at that in more detail as far as how to make. We're saying installation cost, that's like the killer.
And most of the projects, we're talking irrigation, we're talking bird net and sunshade,
Mm-hmm.
we're talking even media, cocoa coir. What I
Mm-hmm.
show you, that's the price of the material, but then getting that material into each pot and being able to having to treat it to even punch it and make it more soft,
Mm.
that takes much more money.
Mm. Does it like double the price?
No, that would be too much, but at least 50 cents more.
50%? Or
50 cents more per plant. So if I'm talking about 2.8 with labor would be at least 3 point, almost 3.5.
yeah. Mm-hmm.
So yes, finding a way to eliminate recurrent labor on low value activities, but since they are so slow and require so much people to make it happen,
Mm-hmm.
that's what makes labor very expensive in these cases. It's that is not modular, and it's not systemized in a way to use machinery to be able to make it, or as we're doing, use 3D print just to make it a more easier to maintain material. As now I'm talking about, instead of cocoa coir using the filament plus biochar, is going to be a very different experience.
Yeah, so you avoid the filling costs. It turns into 3D printing activity, right? Mm-hmm.
Yes. And the preparing of the growing media with cocoa coir, we need to put it in each pot. We need to then put some water,
Mm-hmm.
move it again, then put some calcium, and then we put the plant, but we have to move it 3 times to make the cocoa coir really easy to the root to be able around. If not,
How
it's
do
gonna
you
come back.
move it 3 times?
Well, that's with hands. I mean, you get the big blocks of cocoa, then
Yeah.
you have to basically
Okay.
put them in parts and put it on each pot.
I get it. Yeah. 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 You're moving stuff 3 times. Yeah. Yeah. No, I see that. I think a bit about that. Like, for example, when we get materials from the store, well, you're going to move it several times if you're not careful. But the easiest thing is if you get it from the store, you build right from it, ideally. Otherwise, you're moving it several times. Yeah. 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 No, that's a big deal. Okay.
Yeah,
Um, okay. So for next time, what do we want to do?
I have ready for you the working documents on how we do the concepts specifically of bird net sunshade, what it takes to be from product into finished product. I mean, the main components such as concrete, such as
Mm-hmm.
the materials of sunshade, bird net, the cables, and then how much it takes to put each post and have it ready on labor wise, so we can find solutions that
Yeah.
are costly.
Do you have that already? No, you said you're going to prepare that.
Well, I'm going to prepare a working document so you can reference it, but I don't have like a ready document. I will put the pictures, how it was built, so you have a straight reference of what
Yeah.
happened, how it happened, and also the cost. You know, you saw them now, but
Mm-hmm.
they're going to be connected to each activity, so it's easy to understand.
Yeah. Yeah. Um, yeah. And maybe there's, if I think of anything regarding the climate control part too, that if we could actually, if we were to able make it competitive on an immediate time scale, that would be the requirement, right?
Yes, because one of my main goals is spending less
Startup.
money to make this happen, startup costs.
Yeah.
And I put this topic because I remember of your friend Joshua Pierce
Mm-hmm.
that is working with these tunnels that is making super cost efficient.
Yeah.
That's where maybe I saw some hope to how can we make it happen here for the blueberries.
Yeah. Yeah. I mean, we still have to. I mean, we kind of just went through that the first time, but I can continue to think about this. Like, if there might be some out of the box thinking, because if the yields per area are competitive, why can't we do it like they do for lettuce? Or what would it take? What's missing? I don't have a clear answer for that. Like, okay, if people say do the lettuce operations, I mean, is the simple answer that, oh well, they get capitalized, they get in debt and whatever. Maybe that's the answer, and if that's the answer, then no go. But maybe there's ways to go about, because already we got. I mean, I was surprised that the cost, that over lifetime it actually does make sense. So the question would be, okay, let's shorten that. What can we do to shorten that? I'll think about it. See if I see anything in there.
But the answer you mentioned, they're capitalized. I know a few founders from vertical companies of
Yeah.
agriculture. They just got a lot of money when it was very popular doing vertical agriculture.
Uh huh.
But now the current cost, they didn't let operate at the profit they were expecting, and that's why most of the vertical companies have closed already.
Mm-hmm.
They got a lot of capital, but the market didn't react as they wanted of
Mm-hmm.
price final kilogram or pound, and that's what didn't work.
Yeah. Yeah.
There must be another way.
Yeah. 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 I mean, I was encouraged by if we have extreme low cost ability to make shaded structures. Yeah. Okay. Maybe. I don't know. Maybe the Earth building is a way to do that, because then you get temperature reduction. And then we were thinking, oh well, let's climate control it with PV, but what if there's some other way, easier way? Because I mean, we could be thinking about it. Oh well, what if you've got dirt cheap structures, and those are your posts and stuff like that. Yeah, I think there's a lot of different ways to think about it. So once the dust settles and over the whole project, we can think about, okay, what are some creative solutions that could potentially work.
Okay, yeah, I see it that way. I just want to talk it with you, see what ideas come up. I will
Mm-hmm.
work the documents just to put them very easy references and understand the process, and then we'll find the solutions from there. In the meantime, I still will still work on the 3D
Mm-hmm.
printer, sorry, to see how are the cost components of make it my own here in Mexico, and also see the outsourcing here in Mexico of current companies that do 3D printing. How much would it cost? I don't know exactly the final material of how much grams of each material it's gonna need. That's
Hold
why
on,
I'm
you mean costs to build a printer or to do the prints?
both cost of build a printer and then of course producing it myself, or cost of doing the outsourcing with companies here in Sonora that already have 3D printers
For producing the materials.
that we've been talking, such as the filament biochar. I will keep working on that. That was my message.
Yeah.
I don't know the total material I will need for design because I haven't yet mastered FreeCAD to understand how much design I would need to do. But I would say that's the next step, and I will keep studying how to use it in order to have the answer for next session as well.
You're talking about, so you're mentioning the thing about FreeCAD is about parametric design. Is that what you're saying? You program it parametrically?
Yeah, I don't understand how yet to use it in order to say, okay, if I want to do a 30-liter filament biochar, I would need this amount of kilograms of material or cubic centimeters. And for having that, or when having that, being able to go with the outsourcing companies so they can give me an exact price of how much would it
Oh
cost
yeah.
them. I'm on that
Yeah.
process.
Yeah, actually, like if you put it into FreeCAD, if you slice it in whatever the slicer is, the 3D printing software, it tells you the weight. You get all those facts out of that before you print. So if you have a 3D CAD file, you can get that information from the slicer software. Cura, for example. Yeah.
I will get there. I haven't yet, but I will learn it fast and be ready for next call. Just to be able to do the economic reference of outsourcing and building on OSC 3D printer,
Yeah.
and then we can start developing the real solutions. I
Yeah.
know I went into more analysis, but it was the final analysis. I'll give you my word to start making hardware solutions.
Yeah. No, that's cool. And also, there's a simple way to do it. Like, online, if you go to any 3D print shop, that's already a start. They will tell you, like, if you give them a file, they'll tell you, okay, here's the you know, amount of material it takes. So there's different ways to do that. Yeah. Okay. So once you get, like, for example, the process for the, say the putting the netting stuff up, uh, just let me know. Just email me or whatever, ping me, so that I know you put that in the doc, so I can study it before we meet, so I don't have to think on the fly. I can prepare for the meeting.
Sure, and I'll have everything ready for the call
All right.
on
Yeah.
that case.
All right. Sounds good. Sounds good. Exciting. Well, I learned today that that photovoltaics can give enough power for LED. That's whatever's growing under them. That's cool. That's a cool data point. Yeah. Okay.
very much, Marcin. We'll see you soon.
Okay. See you soon. Take care.